Hola, buenos días. Es un gran placer estar aquí en México para la primera vez. Y para mí y mi amiga maravillosa, Emery, es un gran placer tener la oportunidad de hablar con ustedes hoy. Según la evaluación más generosa del mundo, tengo nivel 3 en español debut. Así continuaré en inglés. Language is context-driven patterns. Language is expectancy. We know what to say, mostly, and we know what people will say to us. We go about our daily business with a great deal of predictability. We start our day with the frenzied conversations over breakfast. Then we ride the bus to work. Mid-morning, we have a chat at the water cooler with a colleague. After lunch, we have yet another Teams meeting. And we smash through the agenda together. And then we go home and we're tired, and we have that negotiation about whose turn it is to fold the laundry. Mexico, Mumbai, Melbourne. Same, the world over. Language patterns are wired into us from a very early age. And it's pretty easy to fill in the blanks. We go for a coffee, and we know what the barista is going to say. Likewise, we come to an ICAEA conference, and we meet someone for the first time. You know the drill. How many times have you said this over the last 2.5 days? They're just language patterns. They're wired in there, and they're really predictable. Any parents in the room? Parents. This is actually my daughter's bedroom. I took this photo on Saturday before I travelled out, and yes, I did tell her to do that. Again, formulaic language patterns. And here's my son at 18 months. Goodness knows what was wrong, but it was catastrophic, clearly. But I knew what to say. He knew what I would say. You can all predict it. You can fill in the blanks. What's the matter? So this is language socialization. It happens in a coffee shop, it happens at home, it happens at school, it happens at work, and it happens in aviation too. Pilots and air traffic controllers learn how to communicate on the radio. We do this with theoretical training, with applications. It happens in the flight deck, and it happens on the air traffic control simulator. We get better at it through training, through exposure, and through experience. Some very bright researcher a few years ago said something like, there is no such thing as a native speaker of aviation English. What a brilliant thing to say. And as we all know, native speakers of English are not necessarily that good at aviation English. So when my son comes into the room in tears and I know what to say, it's just the same in aviation operations. The aircraft is ready for departure, fill in the blank. Ground, Latitude 323, stand 17, request. Pushback, context and language. So what happens when we don't get what we expect? What happens when we deviate from the standard? I mean, what really happens? What happens in here when these deviations occur? Let's have a quick look at this. So, in the middle, standard phraseology. Document 4444, document 9432, all the textbook stuff. We all know it well. That's the standard. Then we have non-standard communications, where pilots and controllers move away from that standard phraseology for whatever reason. We know it happens. We know it shouldn't, but we know it does. And then we have language errors. Things which are just wrong, or bonkers, or muy loco, whatever it might be. Let's take a few examples. So, the pilot says, center latitude 323, request flight level 340. Pretty standard. The pilot says, center latitude 323, can we have flight level 340? What is that in a speech act? Is that a request? Is it available? What does that actually mean? This is going to trigger some response in the controller. And then we have bonkers. Latitude 323, request carrots. What? Same on the other side. Looking at this from the air traffic control transmissions perspective, latitude 323, hold position. That's fine, right? Then latitude 323, stay right where you are. What? Hold carrots? This, by the way, for our research, was our control. And it needed to be there so Hilary could investigate this deviation from the standard. Anyway, this is what Hilary and I have been looking at. And Hilary is super bright, far more intellectually bright than I am. She runs rings around me. So at this point, I'm going to hand over to her. Hilary, the floor is yours.
Thank you. All right. So, a little bit about us at the Language and Brain Lab. We are an active research laboratory, and we look at all aspects of linguistic processing and production. We have special built facilities to look at this, but at the heart of it, we are linguists. We use experimental psychology and neuroscience, but we all have linguistics backgrounds. This is our web page if you'd like to see what we do. The methodologies we employ are vast. We look at reaction time measurements, we look at eye tracking, self-paced reading. My particular areas of focus are EEG, where we look at electrical signals coming off the brain, and I'm going to start to pass these around. These are the EEG caps that we use to run our experiments. You can play with them, you can pick at them. These are our demonstration caps, so don't worry about breaking them. And I also have a lot of work that I do with functional MRI. So scanning the brain, looking at how language is stored in the brain, looking at how the brain processes language, both in native speakers and non-native speakers. We feed a lot of our findings into speech recognition and large language modeling as well. So, when we think about what happens when we're listening to speech, when we're understanding speech, when you're sitting here trying to make out my accent, putting all my words together into a sentence and understanding what that sentence means, there are processes that your brain goes through to do this. And it begins with what you're hearing, and you're taking in these sounds, and you're making words out of these sounds. And within these words, you're making bigger phrases, and they turn into sentences. And we look at every single aspect of that, from phonology, from syntax, pragmatics, semantics, and sentence processing. So when we think about language, how we learn it, how we process it, how we store it, all of us have a different experience with language that we learn from birth. It can be bilingual, multilingual, like me, monolingual with a bit of bad French. But what happens is, as you're processing these words and these sounds coming in as linguistic constructions, these are activating memory cues in your brain, flagging things that your brain says, oh, I recognize this, I know this. It's the basics of speech recognition. And these memory cues are learned throughout life. This is our global knowledge of language. And these are things that can be quite individual in terms of how the brain processes. At the same time, as many of you have noted over the course of the last 3 days, context matters. Context is so important to processing. What we hear at the beginning of the sentence dictates what we expect at the end of that sentence. So I went for a swim in the blank. As soon as you hear went for a swim, you start to activate multiple words that have to do with water. River, lake, bathtub maybe, ocean, sea. And your brain's doing this automatically. And we know this from all our experimental research, that these things are semantically related. They're networking in the brain. And it's very hard to turn this off. When you start to have interactions between this life knowledge, this global knowledge, and this context in the sentence, you can have different outcomes. So a female chicken is a hen, most people would say, but you could also have someone say it's a bird, it's a fowl. If somebody has chickens at home, they could say the name of their favorite chicken. There's going to be wide varieties of things that could fill in that blank. However, in standard phraseology and aviation English, as you all know, it's monoreferential. You can't, or you shouldn't, replace words with other words. You're supposed to stick to that standard phraseology. And this is the case for all specialized languages. So what Henry and I are looking at, and the research is ongoing, is how sort of those global words, those global phrases, that global knowledge is sort of blocked when you're working in your expert area, when you are working as a controller, when you're working as a pilot. How do you mash down those other things and focus only on A, using standard phraseology, and B, expecting standard phraseology? And can you? And questionably, also very important for us, is what happens when the brain hears non-standard phraseology? What happens when you hear a word that you're not expecting in that very controlled, very standardized environment of aviation English? So, I'm going to start to pass around head caps, and I'm going to show you a bit about what we do with EEG. EEG looks at electrical activity coming off the brain. When you are doing a task, when you're thinking, you have neurons that fire in your brain, and the synapses within those neurons that communicate send off a little bit of electricity. And we are able to record that activity, whether it increases or decreases in terms of polarity. And you can see here, this is one of my research assistants that I am using as a guinea pig. But it's a very simple procedure. We have them come into the lab, we put the cap on their head, we add some gel, which enhances that signal, and they do a task. And that task can be anything involving listening, reading, processing, and speaking, although speaking is very difficult with EEG, and I can tell you about that at another time. So the research that we do with EEG, we're able to measure certain responses to language that are very well known. Increases or decreases in that signal that happen at very specific time points after the person either hears or sees something they don't expect. It's a really effective method of exploring neural and cognitive effects of language processing. And I'm going to show you some evidence of the experiment we're running with Aviation English. The data we can collect for this particular experiment is evidence of whether or not other things are being activated, those other semantically related items, those global knowledge items, and what the effect of hearing something you don't expect, non-standard phraseology, on that expert brain. So, when we're recording these signals, this is what it looks like. You have a continuous signal from all those different electrodes that are positioned at different places over that cortex, over the brain in different positions, and you get a readout that looks very much like this. And this will be one subject, one participant, and then you collect a bunch of them, because EEG can be very noisy, so you need a lot of data. The good news is, one participant can give you a lot of data. Then you take all of those signals, all of those participants, and you condense them into a grand average. And you look at whether or not there's an increase or decrease based on what conditions you are looking at. So, our study that we came up with together has experts, so we've got pilots and controllers coming into the lab up in Oxford, and they sit in our little, very quiet booth, and they hear a transmission. And it is a transmission that either contains standard phraseology, non-standard phraseology, or that error, that carrots you saw. And what they're doing when they're there, I kind of trick them a bit because I don't want to force a response out of them. So I have them thinking that they're doing sort of a different task, or they're doing something that I'm looking at sort of a different response for. So I tell them that, once they hear that transmission, once they hear that utterance, They're going to see a word on the screen, and they need to respond using a little box, a button box, yes or no, whether they heard that word in the transmission. So they actually think they're doing a matching task. It gets them to focus on what they're hearing, but not to the extent that they're trying to listen for an error, because we're trying to sort of make it a bit more natural. In terms of what we're collecting in terms of data, we can collect how quickly they respond, yes or no. We can collect how accurate they are in their responses, but most importantly, we can collect brain activity. So I'm going to show you an example of what the experiment looked like and sounded like.
Latitude 721, runway 09, clear to land.
So that's what they see. Sorry, that was very quick. But they see that land pop up. Non-standard phraseology.
Latitude 721, runway 09, cleared for touchdown.
And here's your error.
Latitude 721, runway 09, cleared to coast.
Ghost. You can guess who created and recorded these all for me. Yeah. When I had him doing the error ones, he had to try really hard not to laugh. In terms of that matching task, so that they're not just bored and just responding yes, yes, yes all the time, they were also seeing different words on the screen that didn't match, so that they had something to do.
Latitude 721, runway 09, clear to land.
So they either saw land or something completely unrelated. So this whole experiment took about 20 minutes. It's very fast to run this. This is what the stimuli was designed as, and I'm going to have Henry tell you a bit about that because he's the one who designed all of the stimuli for me.
So very quickly, 44-44-9432, referring to colleagues, air traffic controllers and pilots at Latitude to check through that content. Recorded with what we call supportive background noise, so the clicks and squelches and the chatter that you would hear on the frequency, and designed, recorded, cut, produced in Plymouth. That's it.
The measurements, this is the technical aspect. I can definitely tell you more about this later if you'd like to know. We ran the EEG with 32 channels, which was plenty for our analysis. 182 trials popped up, so that the experts would do the task 182 times. All of those different conditions were pseudo-randomized, so they weren't seeing this and hearing the same thing over and over again. I was told it was actually quite fun, which is, it's a good thing. You get more people coming in. In terms of that response that I'm looking for, in terms of recording the brain's response to the violation, the expected violation at non-standard and error, a trigger would happen where the recording of that brain activity would pop up as soon as the error did. So all of these were hand-triggered by myself and coded for that. And we ran it up at Oxford in our little booth. So, our participants, we're about halfway through collecting the amount of participants we need. EEG is fantastic. You only need about 22 people to collect powerful data. And we've got 11 so far that I've had come up. When you're running an experiment, and when you're running an experiment that no one has ever run before, you want to control for as many things as possible. So we made it very, very clear that we're only taking monolingual British English speakers between these ages. They had to have over 250 hours of flight time, but we're starting to get more and more participants that have a wide variety of flight and duty time. And as we continue to run this experiment through the next year and a half, we can start to put people into training groups and analyze their data based on their flight time and duty time. They were recruited through advertisements, social media, and literally me just going up to people and being like, come do my experiment. I have absolutely no qualms just begging people to come into the lab and sit down and do it. But they've also been very, very interested. I've had pilots from Bryce Norton, Benson, the air bases, British Airways, EasyJet, and then I've got some PPLs coming up as well. So really, really wide variety of people. They've all given informed consent for the collection of research data, and they're compensated for their time and travel. So the best part, let's look at the results that we have so far. And the results, even after collecting half the data, are very strong, and they're pointing in a very specific direction. I'm going to talk about two different types of data I've collected. One is time frequency data. When the brain is processing things, different things are happening at different frequencies. And those frequencies respond or reflect different cognitive processes happening at that time. And I'll present to you some of that information and data. I also look at very, very well-known response data in the signal that are tied immediately and directly to linguistic processing. So the first data I'll show you is more cognitive. The second is specifically linguistic. So, frequencies in EEG, for these frequencies, there's more than 5, but the 5 we're interested in are delta, theta, alpha, beta, gamma. And you can see here that the alpha, beta, and gamma are mostly interested in cognitive control, concentration, processing of multiple things happening at the same time. And you'll see responses in the signal increase or decrease in the polarity of the responses of that brain activity, depending on how much processing is going on and how difficult the task can be. So, I'm going to show you some graphs, and I'm going to tell you first of all what the graphs are and what you're seeing. So, on this y-axis, you're going to see frequency. At the bottom is basically 0, at the top is 30, and those will be those frequency bands that I've been talking about. On the x-axis is the time after they hear that stimulus, the time after they hear that violation or non-violation. And you'll see these different colors. You'll see colors between blue and yellow. Yellow is an increase in that signal, blue is a decrease. We're just looking for changes and differences across those conditions that we tested. So, standard phraseology. We see within these sort of 3 general areas, some very obvious processing, working memories going. People are happy with what they're hearing. They're just doing the task. And it's all very straightforward. Now you can see standard phraseology here. This is when they're hearing cleared for touchdown, or one of those unexpected yet non-standard phraseology items. These aren't our error items, these are just our non-standard. And what we're seeing here, in comparison to the standard, is evidence that working memory already kicks in and is high. It's harder to process this. The brain knows that they shouldn't be hearing it. And the brain is like, wait, what? I don't understand. And in that case, we get a response in the frequency band for error processing. The brain knows it's hearing an error, and it knows it doesn't belong in that sentence with that context, and it has to update expectations and models for what comes next and what to do with the information in that sentence. And lastly, we see this response here within about 200 milliseconds after hearing the non-standard item of having to just readjust what the task is, having to go back and kind of look at the context and readjust what you're doing. There's just general difficulty and confusion. And the most important thing here is that you don't get that in the error. You don't get that with the carrots, which obviously there's experts here and they're like, well, that's just ridiculous. Done with it, out with it. The non-standard items, it's kicking in a lot more processing, it's kicking in a lot more work, and it's not as easy to just excuse it as an error. The brain is trying to deal with it as best it can. And this is what this time frequency data is showing us. So, the second piece of data I'm going to show you is these very specific linguistic responses. These are what we call ERPs, event-related potentials, and they're very, very well-known potentials for specific processing. In linguistics, we have about 3 or 4 we focus on. And what you'll see here on this is your right, again, is these waves. And you're going to see blips in the waves, up, down, and this is the next bit of information I'll be sharing with you. So, the particular ERP that we looked at in this experiment is the N400. And the N400 happens 400 milliseconds after hearing a semantic violation. It happens over sort of the parietal area of the brain in the back, so we know exactly where it happens, we know exactly when it happens. And we know sort of what to expect in this. So, what I mean by semantic violation is, if you hear a female chicken is a hen, you're going to have a very happy wave. You're going to see that nice positive processing wave. When you see a female chicken is a star, you're going to see this blip, this negative blip that we call the N400. That is the brain knowing that something's wrong, that does not belong there. So our question for this next sort of set of analysis was, what are the standard phraseology items going to do? Obviously, these descend and remain carrots sentences are going to give us this big N400, this big sort of blip. Our standard phraseology will be nice and easy to process. But the non-standard, we don't know what's going to happen. And I'll tell you what's going to happen. This is very raw data. This is very new data. It's not going to look as nice and flat as the example I showed you with the hen and the star. But you can see here at the top, standard phraseology, nice and positive, nice and up. Processing's okay. In the red, you have the carrots, or in this case, jungle. You get this blip. Standard, non-standard phraseology. We also get a response of error. The brain knows that that doesn't belong there, okay? And that's only with 11 people. So having that very strong response already is a really good sign. So the last piece of data I'll show you is where this is happening in the brain. And this is very interesting for us. So this is looking down on the head from the top. The nose is on the top, the ears are on the side. And this is looking at increase or decrease in that activity in the areas of that processing. And the areas of the brain that are sort of dictated for error processing, for expectation, for linguistic processing, we look for in terms of sort of left side, middle, and then back. So standard phraseology, you're going to see a lot of red, you're going to see a lot of happy processing. Person's doing the task and they're working at it. With the error, with carrots, we have this absolutely beautiful N400, right where we expect it, this decrease in signal at the back, and that was great. That means that the experiment actually worked, so that's nice. The non-standard phraseology, very interesting. So we get the N400, but we get an additional effect in the frontal area, and this is known as NREF. This is an error in discourse level processing, where the listener can't resolve who or what is being referred to. When that item pops up, they don't know where it belongs and they don't know what it's referring to because it's so unexpected to hear in that signal that the brain is trying to place it and associate it with something earlier in the sentence. And this is sort of data that we've never seen before. This is absolutely brand new. It's very exciting to see this effect in these responses, and obviously we need to think a bit more about why we're getting it. So, to recap, this is my last 2 slides, thank you. You saw time frequency data, where we were looking at these different frequency bands, the differences across them, and you saw these ERP data, where you saw these waves, and the blip of that wave responding to these non-standard items. And in that time frequency analysis, we're seeing just effort. We're seeing a lot of hard work. We're seeing the brain trying to reanalyze, trying to get back to what it needs to do, and we're not seeing that in those errors. And with the ERPs, with that very specific linguistic response, we're also seeing the categorical N400, but additional sign that something else is going on. And so, to recap what we're finding so far, is that non-standard phraseology causes the expert brain to respond with an error during processing. It's not quite to the error of carrots, but it's still a definite, this does not belong there. This is really hard to deal with. And remember, these are in monolingual speakers, just doing the task generally. It increases working memory demands, it increases activity related to cognitive control and error monitoring, and it requires the listener to spend extra effort to map the discourse, map what's happening in that sentence, and what to do with those items. And it also, there's a sign that standard phraseology is still being activated. The brain knows that standard phraseology, what that item should be, it's activated, and they're going to have to deal and tie the two together. And so, yes, that's what we found so far. Over to you.
Thank you very much. Thank you very much.
What have we learned? Stick to standard phraseology. We all know that. It's very interesting that the LPRs were introduced in 2003. 10 years later, at the 38th Assembly, the Assembly are urging member states to stick to standard phraseology. So what's going on with the policy? Is it that we missed something? Is all this emphasis on plain English relegating the importance of standard phraseology? Can research like this lead to the repositioning of phraseology at the very heart of safe communications, putting it back into training and putting it back into assessment? That's what I'd like to see. Hilary and I would like to look at some other things in the future as well. perhaps revisions to the rating scale, the sort of thing that David was talking about earlier, rehearsal formulaic speech, spontaneous interaction. Why not standard phraseology into plain language? Let's be explicit about what we're trying to train and assess. Some other things we want to look at, really want to take what we've learned so far in Oxford to other parts of the world. Do these patterns occur in L2 users of English? Would we get the same results with the expert brain here in Mexico or in Chile or wherever? So that would be an interesting dimension to explore. Pilots and controllers, do they process in the same ways? Do their brain patterns have things in common? If they do, what are they and how may they be different? And then finally looking at phraseology and plain language together, which is of course aeronautical communication. The policy separates these two things, which is a real pity. I would like to see these things come back together in this experiment so we can start to look at how we process that switch from standard phraseology into plain language in non-routine situations. How does that work? And how can this sort of research, this hard science, help us to understand with real clarity the lexicon of aeronautical communication? Ladies and gentlemen, muchísimas gracias.